All right, example 2 got cut off, so let's just start at the beginning. We've got an angle in quadrant 4, and sine of theta is -1/4. So if you draw your angle in quadrant 4, connect it to the x-axis to make it a 90-degree angle, which turns this into a right triangle. Put your angle of focus, your theta, next to the origin, and then we use our sine, which is opposite over hypotenuse, to label with the 1 and the 4. So we know opposite of theta is 1. The hypotenuse of this triangle is the 4. And we're putting the negative on the 1 because it is going down in the negative y direction. And 4 is the radius, and the radius will always be positive. And then we need to find this missing horizontal length. So to find that, since it's a right triangle, we can use Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. And then we end up getting a squared equals 15, and you're going to take the square root of both sides, and you get radical 15 for the missing length. And that is going in the positive x direction, so it is positive. And now that we have a full picture and we have our theta next to the origin, we can list our 6 trig functions. So you've got sine of theta equals opposite, which is -1, over hypotenuse 4. You've got cosine theta is adjacent over hypotenuse, radical 15 over 4. And tangent theta equals opposite over adjacent, -1 over rad 15. You want to rationalize your denominator, move that radical to the top. And you're going to get negative radical 15 over 15. Then they want the reciprocals. So cosecant goes with sine. You want to flip that upside down. You're going to get -4 over 1. Secant goes with cosine. When you flip that, the radical will be on the bottom. And you need to rationalize your denominator. So 4 radical 15 over 15. And then let's flip that tangent to get cotangent. So it'll be negative radical 15 over 1. You don't need the 1. Moving on, there are special triangles that we are going to use throughout trigonometry. One of them is your 45, 45, 90 triangle. So draw a 45, 45, 90. And what I want you to remember is the special ratios on the outside of the triangle. So across from your 45s, opposite of your 45 is going to have a 1. Opposite of that 45 is a 1. Opposite of your 90 is a square root 2. And that you need to know. Draw a 30, 60, 90. So for this triangle, opposite of your 30 is a 1. Opposite of your 60 is, well, let's skip that. Opposite of your 90 is a 2. And opposite of your 60 is a square root 3. So 1, 2, square root 3. In addition to your special triangles, you're going to want to know your unit circle. We've talked about this already, but this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. We also talked about this is all students take calculus. So all are positive, sine is positive, tangent's positive, cosine's positive. But the new thing I want you to remember about this circle is that the radius is 1. Radius is 1, which is why it's called a unit circle for just 1 unit. And then I want to label these ordered pairs for the 4 points that are drawn. So if the radius is 1, then the x value is 1, and the y value is 0, since it is on the line. For this point, the x value is 0, but the y value is 1. For this point, the x value is -1, y value 0. For this point, the x value is 0, the y value is -1. And so we want to remember those. So we're going to use this circle, and we're going to use the triangles on the other side. to answer these questions. So we're going to look at 240 degrees. So first, we're going to find its reference angle. And so 240 is in quadrant 3. And so to find your reference, you subtract 180 from it, and you get 60 degrees. Now from there, we're going to use 60. So we're going to look at our 30, 60, 90 triangle. And we're going to focus on angle 60. If we're focusing on angle 60, then radical 3 is the opposite, 2 is the hypotenuse, and 1 is the adjacent. So then from there, we're going to find our trig functions using SOHCAHTOA. And so sine is opposite over hypotenuse, radical 3 over 2. Cosine is adjacent over hypotenuse, 1 over 2. Tangent is opposite over adjacent, radical 3 over 1. Then cosecant, you do reciprocal of sine, and you're going to move your radical to the top. So it'll be 2 rad 3 over 3. Secant is reciprocal of cosine, so that'll be 2 over 1. And cotangent is reciprocal of tangent, so it'll be 1 over radical 3, and you need to move your radical to the top. Your last step, step 4, is to check the sine. All students take calculus. Now 240 is in quadrant 3, so that means tangent and cotangent are positive. So everything else should be negative. So sine is negative, cosine is negative, tangent's positive, cosecant negative, secant negative, cotangent positive. B, 135. Start by finding its reference angle. So reference angle would be 180 minus 135 because it terminates in quadrant 2. So we have 45 degrees as a reference. Now that we know our reference, we're going to find our special triangle, 45, 45, 90, which is 1, 1, radical 2. Then we're going to use SOHCAHTOA to find the 6 trig functions. So sine of theta, since we're focused on 45, and there are 2 of them, you can decide which one you want. It doesn't matter. So if I pick the bottom one as my reference angle, 1 is opposite, this one is adjacent, and rad 2 is hypotenuse. So the sine would be 1 over radical 2, and you need to move your radical to the top. So rad 2 over 2. Cosine would be adjacent over hypotenuse, 1 over radical 2. Move your radical to the top, radical 2 over 2. Tangent is opposite over adjacent, 1 over 1, which is 1. Cosecant is reciprocal of the sine, so if you flip 1 over rad 2, you're just going to get rad 2. And secant is reciprocal of cosine. If you flip 1 over rad 2, you just get rad 2. And then your last step is to check the sine. So all students take calculus. We are in quadrant 2 with 135, where sine is positive. So that means everything else gets negative. Cosine negative, tangent negative. Cosecant goes with sine, so positive, and then secant is negative. Part C, 180. 180. So 180, we don't need the reference angle, and we don't need the triangle, and we don't need SOHCAHTOA. We just need our unit circle. So we look at our unit circle and we focus at 180 degrees, which is the point -1, 0. When you look at these ordered pairs, the first number is the cosine value, the second number is the sine value, and you find tangent by doing sine divided by cosine. So that's all you need. So for sine, you have 0 as your answer. Cosine, -1 is the answer. Tangent is 0 divided by -1, which is 0. Cosecant, so you imagine there's a 1 on the bottom of this 0, so it's 1 over 0, but you can't divide by 0, so it's undefined. Secant, you imagine there's a 1 on the bottom of this -1, so you just have 1 over -1, which is -1 again. And then if you flip your tangent, you're going to have -1 over 0, which is undefined, because 0 is in the bottom. And those are your 6 trig functions. 270 is also on the unit circle, but we're looking at this point, 0, -1. So cosine is 0, sine is -1. Tangent is sine divided by cosine. So that's going to be -1 over 0, which is undefined. Reciprocal of sine is cosecant. So you get -1 over 1. Reciprocal of cosine is secant, which is going to be 1 over 0, which is undefined. And then cotangent, if you flip that, is going to be 0 over -1, which is 0, because you don't have 0 in the bottom.